Hey guys, it's Mr. Sheenline here again. This is going to be just the kind of the same deal we had last time. This is going to be me talking you through, walking you through how to read, interpret a little bit when it comes to velocity time graphs. So last time we already worked with position time graphs. So that's where we talked about displacement in relationship to time and how we can express it on a graph. So we're going to just dabble a little bit into velocity time graphs. Um, Now, velocity time graphs, it is getting into some material that we haven't gotten into yet. So this will be a pretty good, I guess, introduction to that kind of material. And specifically, it's going to be material I'm mentioning here is acceleration. So we haven't covered acceleration yet, but we will soon. And this is going to be a nice little way to segue into acceleration before we really get into it. So let's take a look here. Velocity time graph. So like it says up here, the other day we practiced reading position time graphs, and we understood that we use these graphs, or we can use these graphs to find displacement, time, and velocity. And remember, on position time graphs, excuse me, on the position time graphs, we have displacement, our more or less our responding variable on the y-axis, and then we have our manipulated variable time on the x-axis. It's not too different here for velocity time graphs. Time is going to be on the x-axis because it's still the manipulated variable. Velocity is going to be the responding variable here. It is going to be where displacement was on position time graphs. Okay. So look in here, easy peasy. This is just a quick little, getting into the motion of things. So what are the three things that it just says up there at the top? What are the three things that we need in order to have, and I just realized I forgot to change this. Position time graphs. What three things can a position time graph tell us? Well, it can tell us displacement, it can tell us the time, and it can tell us the velocity in a graph, in a particular set of motion. Can tell us, we can look to see, okay, what was the displacement at this time? At what time was the displacement this? Between this time and this time, and then due to the motion that they went through, the displacement that we saw, what was the velocity? Okay, we can see all three of these here. Now, and I forgot to change this too, God bless it. It's not speed, but now, what are the three things that velocity time graphs tell us? Well, of course, basically just like up top, it's going to tell us all about velocity. It's going to tell us about time. And the third thing, this new thing, is going to tell us acceleration. Okay, it's going to tell us what acceleration is. Okay. And so this is where this is where I want you to like pause the video, or at least do the. It's best that actually if you pause the video now. What I want you to do is take a look here at number 3. I want you to take a few minutes to read through this provided Khan Academy link. There's even a little quiz that's provided as well that I highly recommend that you give a try. Go to this Khan Academy link, read about what acceleration is, and read about what it may look like and how it relates to velocity. And then down here, I want you to put together a summary of what acceleration is after you've read that article. So, because we're jumping into acceleration, we haven't talked about it. So I want you to have at least a working understanding of what acceleration is, and it's a very common word that's used, obviously, and you've probably used it before, and you may have half an idea what it is. It's a little bit different. It's a little bit more specific in physics. So give it a read. Write down a quick little summary down here. I know the box is big, but it could be a quick summary of what it is. Please don't copy and paste the answer here. Okay, make a summary on your own. So pause the video here and then come back, and we're going to move on to the next slide where we're going to talk. I'm going to walk you through, and talk about trends on a velocity time graph. Okay, so take a look at number 3, pause the video, and then come back. Okay, so we should have an understanding what acceleration is, and for the most part, acceleration. Actually, I'm not going to say what acceleration is because you should have read it. So if you're hoping that I would just say it, haha. So looking at this graph here, we'll use this graph as kind of a template. We'll use this graph as a means to talk about what a velocity time graph is supposed to show us. So as we see here, like I mentioned earlier, we've got velocity over here on the y-axis. We have time here on the x-axis. And make sure you notice the units. So velocity is in meters per second. Time is in seconds. Okay, so very important to realize, or to have an idea of how much time is being passed here, because it's not 1 hour or 2 hours. It's 1 second, 2 second, 3 second. It's not 1 kilometer or mile. It's 1 meter, 2 meters, 3 meters as you go up the y-axis. So looking at number 4, what does the part of the graph labeled A represent? So A is going to be both this blue line and also this red line. Okay. So let's kind of look and maybe think about what straight lines told us on position time graphs. So remember, on position time graphs, a straight line that goes up is going to tell us, what that's going to tell us is that, we are increasing, or at least we are, if it's going up, we're positively increasing the position or the displacement of our moving object in relationship to time. As time goes on, our displacement is changing. But not only that, when it's at a straight line, it's changing at the same rate. It's changing at constant rate. What I talked about in class, constant velocity. Now, let's think about this for a second when it comes to velocity time graphs. If we see velocity is, instead of position, velocity is now going up. It's increasing over time, and relative to time, it's increasing. So if velocity is increasing and we see a straight line, it's not that we have what we have here isn't a constant velocity anymore. What we have is constant acceleration. There is a constant change and the same change of velocity over time. Okay. And that's very important. So what does the graph portion labeled A and B, A represent? Well, we'll say that this represents constant acceleration. Oh my goodness, I can't think of spelling that real quick. So yeah, A is telling us both the blue line and in this first leg of the red line here, it's telling us this is constant acceleration. We have a constant change in the velocity, because and that makes sense, because we look over here on the y-axis and we'll look to see at each actually, maybe let's look at the red one because it's distributed a little bit better. So from 0, so this object started at rest. After 1 second of accelerating, the object was moving at 2 meters per second. If we look at 2 seconds, it's now moving at 4 meters per second. If we look at 3 seconds, it's now moving at 6 meters per second. If we look at 4 seconds, it's moving at 8 meters per second. So we would say that this has an acceleration of 2 meters for every 2 meters per second every second, or every 2 seconds. So actually, let's see. Or no, for every second, yeah. So every second you have your velocity is increasing 2 meters per second every single second. So we would say that we have a constant acceleration here. We have a change in velocity. Okay. And then if we look here at blue, it looks like at 1 second, I'm going to guess that it's going to be right here, even though I've got A covered up. At 1 second, it's probably a 5. And that makes sense because if we look at 2, it's at 10. So we would say that this blue line has a constant acceleration of 5 meters per second every second. Okay, so that means that after every second, our velocity is increasing 5 meters per second. So think about that. What velocity would we be traveling at 3 seconds? Think about that for a second. What you should be thinking is that by 30 seconds, we should be moving at 15 meters per second. Okay. So now B. So now we've shown that, this A portion, we have constant acceleration. Our velocity is changing the same, okay, over the span of time. But then B, we've got this plateau. We've got this little shelf here. So when we look at that shelf in position time graph, that told us that our position hasn't changed. We've come to a stop. And that was in position time graphs. Velocity time graphs, it's saying something else. So velocity, if we've been traveling, 2 meters per, we've been increasing our velocity 2 meters for every 2 meters per second every second. By the time we get up to 8 meters per second, okay, we're still moving. We're still trucking along at 8 meters per second, which is decently quick. We're trucking at 8 meters per second for 1, 2, 3, 4 seconds. So right here, between 4 seconds and 7 seconds, we are at a constant velocity now. So we'd say that this represents constant velocity. Okay. That represents constant velocity. I better get my punctuation right. Okay, because that's what this is saying. Again, in position time graphs, that tells us that we have stopped. We're not moving anymore. Velocity time graphs, which is what we're looking at, tells us that we're still moving. It's just we're moving at the same rate. We're moving at 8 meters per second for 3 seconds. Okay. Yeah, 1, 2, 3. Yeah, 3 seconds. Okay. So let's take a look at C. Okay. Well, what does C say? Well, if a portion is moving upwards, meaning that we have an increase in velocity over time, that over this amount of time we'll have an increase and a constant increase of velocity. What does the C line tell us? What does this tell us? What's the opposite? We have a decrease. We're having a decrease in velocity from 7 seconds to 10 seconds. So here we would say that this represents constant. Technically, how to make sure not to, because I don't use this term very often. I'll just put it down. I don't use this term very often because it's I work more with negative, positive directions rather than this word. We'll say that this represents constant deceleration. Let's see, and I got to remember deceleration. I think that's, yeah, it looks like that's how you spell it. Nope, that's not how you spell it. How do you spell that? Nope. Google, help me. It's 1 L. That's where, or it's 1 C. Okay. Sometimes I get that mixed up, especially since acceleration has 2 C. It does have 2 C's, right? Yeah, that's what I thought. Okay. So C represents constant deceleration. Now, I don't typically, especially with my actual physics class, I don't categorize this as deacceleration. Is it deacceleration? Yes, it is. I just don't like using that term just for the fact that we work a lot with directions, especially when we get to two-dimensional, or in physics, we work with two-dimensional motion. So you would have like an object going this way, and then we'll say it turns and goes this way. Technically speaking, when it turns, that's technically it's deaccelerating because it's now changed its direction, and because it's changed its direction, it's now having to basically start from rest, and then you go from like 0 to then whatever it accelerates to. And that language of deacceleration just doesn't fit that kind of scenario. So I don't like using that language, but in this case, because we're talking about, we're keeping it simple and we're just talking about it. And I know you've heard of this word before, deacceleration. We'll just use that term. But that's what we see here from 7 to 10 is deacceleration. Arguably, it's just to say that we are now, coming to a stop. Well, I'll put that in parentheses. We are coming to we're slowing down. This would be braking. If you're in a car or in a bike or a bicycle, slowing down, braking, decreasing velocity ultimately is what we're doing here. Okay. And actually, let's go back and add some more just parentheses to kind of finish the thought. So this represents constant velocity. We're moving at 8 meters per second for 3 seconds. We'll say that right there. That's what's happening. And then for A, we'll just say that basically just the opposite of what's happening down here. Velocity is increasing speeding up. Yeah, that's good enough. That's what's happening in all three of these situations here. Okay, that's what's happening. And I'm going to do this. Space, move this guy down. There we go. Now for you guys, this is going to already be pretty much set where it needs to be, so you won't have to worry about moving this. Okay, so that's what's happening in this graph, and this is how we interpret it. And it seems pretty straightforward. It's pretty simple, relatively speaking. It gets a little tricky when you then, have like 8 graphs, and then on 8 graphs, one of them is, acceleration time, one of them is position time, one of them is velocity time. You'll have like curves, and then you have to find tangentials, and that's fun. Not really, but we're not going to worry about that. We're just going to focus on velocity time graphs here and make sure that we can read them. So a reminder before I talk about the third slide, a reminder, if you have not answered this right here, this number 3, you need to answer it. You need to have, again, a working understanding of what acceleration is, especially when you get to here. So what you're going to be doing here is you are going to be categorizing or describing what is happening. So which of the following best describes the motion in each segment of the graph? Is it accelerating, deaccelerating? Does it have constant velocity? Are we at rest? So read these graphs, and then over here, tell me E, what's happening in E? For F, what's happening in F? G, what's happening in G? H, what's happening in H? Okay, and use these words up here. Are they accelerating? Is it deaccelerating? Do you have constant velocity? Are we at rest? And then down here on the road, I want you to do the same thing. Use these 4 ideas, and I want you to describe to me the motion happening here from O to A to B, B to C, C to D, E to F. Okay, so let me know. Tell me what's happening on all this. Okay, so that is what you're going to be doing today. Anyway, if you guys still have questions for me, and just a reminder, if I didn't mention in the beginning, this is basically just a video in case you were absent or if we have another snow day, whatever happens. Well, snow/e-learning day. So anyway, okay, guys, that's the video. If you still have any questions for me, make sure you ask on, Remind, Gmail, Google Classroom, whatever it is, and I'll get back to you as soon as I can. Okay, I'll see you in the next one.